Well, welcome. For those who have just joined us, please include your name and affiliation in the chat. We've got several folks here. We've got Sarah Wilcox from the State Conservation Commission. Thanks for being here, Sarah. We have Brant Smith from Okanagan Conservation District. Angie Riesland, our WDFW Farm Bill Coordinator. Rebecca Rising, it's good to see you from Skagit County. Margaret from Ecology in Sammamish. We have Mid-Columbia Fisheries Enhancement Group. Stephen, welcome. Whitney from Thurston County. Deanna from the Columbia Basin Conservation District.
Great. Well, it looks like we have a pretty wide variety of folks from across the state joining us from today. We have probably a few more people trickling in, but I'm going to go ahead and get us started. My name is Robin Hale. I work with the Washington Department of Fish and Wildlife for the High Resolution Change Detection Project as part of the Habitat Program. And joining me in the presentation today is Emma LaValle and Adam with Washington Department of Fish and Wildlife, as well as Maggie Long with San Juan Islands Conservation District. We also have a crew of support that you will hear from and see today as well, with technical questions and monitoring chat as well. So continue to feel free to add questions and comments into the chat as we go on today. We'll hopefully keep this interactive throughout the day. So this is a two-part workshop series, and we're actually on part 2 today. But I just wanted to touch base on part 1, so you have a context of where we're coming from. And it's okay if you did not attend part 2. These are meant for part 1. It's meant to be standalone. But in part 1, we did an introduction to the Voluntary Stewardship Program, or VSP. We did an overview of the High Resolution Change Detection data, or HRCD data, as we'll often refer to it, including a lot about the process of which the hard work that goes into creating the data set and the accuracy information that results. And finally, we brought it together looking at the high resolution change detection within the VSP context. And San Juan Islands presented on a way that they have incorporated the data into their work plan. A recording for that is available from the May 13th. But today we are here for part 2 of the workshop series. And today's goal is to learn how to use the high resolution change detection data to answer common voluntary stewardship program monitoring questions. This particular workshop is designed for those with some basic GIS skills. We will be using ArcGIS Pro for some live demos today, but I hope that no matter what your GIS levels of skills are, that you will still gain something from the program and from the presentation, as well as no matter which platform you use, you should be able to pull some information from this presentation as well. Our outline for today, we will start by exploring the data, using some basic skills like looking at the data itself and learning how to download it. We'll then get into some of the details, our technical side of things, by analyzing the data, and hopefully you'll see how easy it is to analyze this data set. And then we'll take a break, about a 5-minute break probably for our bodies and minds, as this is scheduled for 2 hours, so I don't know if we'll take the entire time. After the break, we'll come back to interpret the analysis results, right? We can get some numbers through analysis, but how can we learn more about those and trust that they're good and understand them within your own context for your county or your questions? And then we'll bring it back together, and San Juan Islands will present how they have done analysis with the HRCD data. And finally, we'll leave plenty of time for a discussion, question and answers, and including technical questions if there are some for individuals. So one thing from part 1 that we want to, that I just want to bring in today is what is change? And while we use, there's change in our lives every day, for the next hour and a half of our lives, when I say the word change, or when we say the word change, we're referring to 3 very specific things. And in our high resolution change data set, we're talking about changes to the land, in particular, tree canopy loss. So that might be cutting down a tree on your property, or it could be due to a forest fire or a landslide. We'll also be referring to changes in development, and that shows up as 2 different two different ways. One is impervious surface increase. That could be a new building or new roads. And semi-pervious surface increase, which often shows up as new gravel, which we see a tiny gravel road running through this field. And this semi-pervious surface increase is kind of the gray area. It's not as impactful on the environment and imperviousness as a building or a road. And it's maybe not as permanent, but we didn't want to exclude it. So you can choose on your own if you want to include the semi-pervious surface increase as development or not.
Awesome. So looks like we have a few more people who've come in. So this will be a really good way for us to figure out a little bit more about our audience today. So you see on the slide where we have some poll questions. You can either use that QR code in your phone, or if you're on your computer, you can go to slido.com and enter that number 1-899-797. And the first question that we're going to ask today is, what is your level of GIS experience? So we're just curious about the audience in general and who's with us today so that we can help sort of tailor our conversation around it. I love it. I see a variety, which is great. And if you keep your Slido open, there'll be, I think, 3 more questions right now. And so if you keep that open, then it'll just move on to the next question, I believe. Like we have a good spread of people today. That's awesome.
Yeah.
I'm excited for you all to be here.
Like most people considering themselves in the intermediate range, which is great, with a great collection of beginners and advanced GIS skills as well. So again, I hope that what we present today will fit everyone.
Yeah, we can move on to the next question.
Okay.
So our next question is, we're curious what GIS platform you use. And once again, you can use that QR code. You can also go to slido.com and enter the number 1-899-797. Looks like we have quite a few ArcGIS Pro. We have some people who are using ArcGIS Online, a few ArcMap users still, some others. Be curious what those are. If you said other, if you feel like it, you can put that in the chat. I'm curious just to see what other people are using. And a few QGIS users, which is really cool to see as well. Our main demo today will be in ArcGIS Pro, but the tools you can use in any of your GIS platforms. Sweet. Cool. And then our last question is, how familiar are you with VSP? So we have very familiar, somewhat familiar, and not familiar at all. And we're just curious about your interaction with VSP for this one. And if you've just joined us, feel free to put your name and your affiliation into the chat. And if you are trying to access the Slido, you can access that via your phone on the QR code, or you can go to slido.com and enter the number in the left side of the screen. This is awesome. It looks like we have a good spread of people who are familiar and not familiar, sort of familiar with VSP, the Voluntary Stewardship Program.
Great. Okay, thank you all for interacting with that. This gives us a lot of help in how we present today. So we have, after knowing about who is here, we are going to start with a primary analysis question. And this is perhaps a common question for the Voluntary Stewardship Program. The question is, for each RIA in my county, RIA or watershed in my county, how much of the riparian area that's on agricultural lands has lost tree canopy since 2011? And as a sub-question, breaking it down by cause, how much of that was caused by natural forces versus human activity? And the voluntary stewardship program, counties are required to go back and show no net loss since 2011, which is why we have that 2011 year. And the tree canopy is one of the types of change that we look at, and showing that no net loss in riparian areas, looking at on agricultural lands, is one of many critical areas that we could look at. And we're using that question to kind of filter and focus our presentation today, but our data set is so flexible that we could answer any wealth of questions with this data set. So instead of looking at riparian and areas on agricultural land, we could look at agricultural lands in general, or we could look at wetlands or floodplains or the county as a whole. So you really can tailor this question. While we will answer a specific question today, you can tailor this to whatever your needs are. And if tree canopy loss is not something that's of interest to you, we can also look at new development or impervious surfaces like buildings and roads, or any type of change that's happening, or only natural changes. So again, we can really tailor these questions, and the data set has so many attributes and fields that we can explore quite a bit. So I hope that you find something to hold on to. If our primary question doesn't resonate with you, I hope you find something that works for you. In addition, there are other questions that we can ask of the data set. We can ask questions about the amount, which is what we'll be looking at today. So how much change in acres has occurred on agricultural lands could be a potential question. Or what proportion of the critical area on ag lands have changed? We can ask questions about the types of change that we're seeing. For example, how much of the change in my county was due to natural causes versus human causes? Or which types of changes are most common in my area? For example, tree canopy loss or an increase in development. We can ask questions about locations. Where have the changes occurred within my county or RIA? Are they clustered in a way that tells me something about the nature of these changes? Or how does the proportion of change on the agricultural lands compared to proportions of change that's happening outside of agricultural lands? And finally, our data set allows us to ask questions about time. So when has most of the change occurred? How does the rate of change compare over time? So again, while we'll focus on a very particular question today, the questions that we can ask are very wide and varied, and I hope that you find something to follow you through this thread today. So our first section today, we will explore the change data. That is step one. And to get started, first we'll want to access the high-resolution change detection GIS data. There are two ways to do this, and Emma will give us a demo briefly in just a minute. But we have two ways. You can either download the data to use locally. So if you're using ArcGIS Map or Pro, what we might recommend from the Washington Geospatial Open Data Portal. And if you're using ArcGIS Online, you may want to add it as a feature service. And this is great for visualization and web applications, and it also works with Pro. When you download the data, you will open it up and see the outlines of 500,000 changes that we have collected since 2006 for statewide. And these outlines will look like this orange or pink outlines that you see in this picture. You won't get the imagery that's behind it. That's what we use to create the data. But you'll get a wealth of information and attributes associated with each outline, with each polygon is what we often call them. So we'll get information about the time span, the size of the polygon, the amounts and types of change, or the causes of change. In this example, we see about 25% of the area has lost tree canopy, about 25% of the area has gained new impervious surface, like buildings and roads, and we attributed this to the human development. You can also, of course, you can use GIS tools like pop-ups, explore, definition queries, selections, and exploring the attribute tables to learn more about individual changes and explore that. Our data set has a lot of attributes. This is one of the things that makes our data set so robust and so unique for change detection data. Our attributes, we have some primary filters, so time span. We have a start year and an end year, and those are the two image years that we compare, and the change happens sometime between this. So the first, on the left here, the first row, the change happened sometime between 2019 and 2021. We also have information about county and RIA to make it easy for you to filter. So we have the RIA name and number, as well as the county name and number. So in this case, change happened in the lower Chehalis watershed within Grace Harbor County. And we also have information about the size of the polygon, that pink or orange outline that we showed earlier. In this case, most of our polygons are quite small, and this top one is 0.2 of an acre in size. Other attributes, we kind of get into some of the details that makes the data really interesting, are the types and amounts of change. So for every change type, we have both a percent and acres associated with it. In this table here, we have a column for tree loss percent. So what percent of that polygon has lost tree canopy? And on the right, we have acres of tree loss. So how many acres does that equate to? And Adam and Emma will show you how to recalculate that acres of tree loss and when that would be needed to do. And those two columns exist for all four types of change. We have tree canopy loss, an increase in impervious surface, an increase in the semi-pervious or gravel surface, and then also a total change of any type. And finally, in our attributes, we what I think makes our data extremely special is the cause of change. So instead of just looking at what changed, we also have analysts look at it and apply a cause of change. And this starts off by saying, was this caused by humans or natural causes? And then we can even have subcategories. So for natural causes, we assess whether or not it was due to stream meanderings, natural stream fluctuations that remove trees, or other natural events like fire or insect or landslides. And then also under anthropogenic or human-caused changes, we have a variety of different causes from large-scale forestry operations, development, redevelopment, or a loss of impervious surface, removal, building, general tree removal, retention ponds or irrigation ponds, and other human causes. These, especially in the anthropogenic category, can have multiple change types. So for example, development, we may see a loss of tree canopy and a gain of impervious surface. So perhaps trees were removed and a building was put in, and then a gravel driveway was put in. So we can see all three change types within one change polygon sometimes. Once we look at our attribute table, we can also visualize the data. Changing the symbology can help identify spatial patterns, and a lot of people choose to show the data off in web applications or other maps. In this example, I symbolized by change origin. So in yellow, we see natural changes, and pink, we see changes caused by humans. And I can see that changes close to the river and in the riparian areas are mostly caused by natural forces. And a lot of the human changes are outside of that riparian area or further from the river. I'm including some other tips on how to visualize the data after years of doing this and making mini maps. Because we have so many causes of change, sometimes it's helpful to group similar classes together. So within that development category, I combine, say, retention ponds and other human causes together into one category, and both natural causes were lumped together as well. In addition, in this map, the outlines of the features were changed instead of the default gray, but to be the color of the feature that we wanted to show. So the outline of the development polygons is orange and also is larger than you would expect. And that allows us to see the polygons from from a statewide or even county scale, since the polygons are so small. Those are those tips for later. And you can also visualize based off of a single type of change. So in this case, we can look at tree loss. And using a single color ramp, scale it from the darker colors being 100% loss to lighter colors being 25% loss, and removing polygons that have zero loss. So we can use filters to remove zero loss. We could also use filters to remove natural causes, or use the filters definition queries to remove human causes, if that is what we're interested in doing. After we display the data, you may also want to know more about these data as well. And a great way to do that with any GIS data set is by looking at the metadata. And our metadata in particular has a great description and purpose associated with it. Excuse me. As well as citation information, to reference the Washington Department of Fish and Wildlife, contact information for those of us on the call, and people who created the data, as well as attribute and field descriptions. Because we have so many attributes and fields, this part is really helpful for a lot of people. In this example, you can see that the attribute label change agent name has a definition of the primary cause of the change as assessed by an analyst. And then one example that you might see in there is development, and then we have a definition of development as well. And so each of the attributes are explained within the metadata. If you're newer to GIS, metadata might not be the most intuitive thing for you to use. So we also have a lot of online resources on our hub site, including a user guide and tutorials, and a whole page dedicated to VSP specific resources. This includes analysis tips, accuracy and quality assurance information, and recordings for both this workshop and the previous one. And now we will move on to a demo in order to learn how to download and access some of these resources.
Fantastic. I'm going to share my screen here. There we go. Looks like it's up now. So there's a few different ways that you can access our data. One of those ways that Robin was talking about is via our website. So this is our hub site, HRCD tag wdfw.hub.arcgis.com. And that'll be in the PowerPoint, so no need to worry about that. But if we come into here, we can see that there's a tab at the top, and that tab says VSP on it. So we'll click on the VSP, which takes us to the Voluntary Stewardship Program page. This is where you can find a lot of different information and access our previous trainings. You can play around with that, but let's go to the how to obtain HRCD for our county. So one version that we can do is via the Washington Geospatial Open Data Portal, like Robin was saying. And that's best if we are wanting to download to do analysis. So if we click on that link, it takes us to this high resolution change detection page within the geospatial portal. And there's a few different things you can do here. You can read the summary, you can view other details of it. You can also filter the data. So if you're just looking for your county, you can go into the filter button, and then you can scroll down to your county and click on the county name. And then let's say you're Lewis County, you would click here. And you can also search for your county in the space below. Something to note about this though is that when you go to the download page, which is on those 4 blue squares again, and you toggle on the filter, so you're toggling on just for Lewis County, it says that it's going to take a little bit to create your new file with that filter. So that's just something to keep in mind if you are going to filter. If you just want to do the entire state and you want to do that definition query later, you can just go directly down to the bottom of the page, and you can click on this zip file geodatabase. So that will make a zip file of the entire state, and then you can put that in wherever you want, and you can do your filters there. The other version that we've talked about is going back to our voluntary stewardship page. You can go to the ArcGIS online portal. And on the AGOL website, you'll find our data set. So this is the high resolution change detection data set again. And you can open up in Map Viewer. So you can create your own apps, do your own analysis via that. You can also download, there's another zip file that you can download, which will be the whole data set. Within this similar vein, if we go into Pro, so if you're a Pro user, you can also find under the Add Data tab, you can add from AGOL directly by searching HRCD. And that first one, high resolution change detection, that will be the layer that you'll input. And it'll add your data in there. So those are just some ways that you can take a look at our data and gather our data from online. And I think that I'm talking about analysis next. So once we've gathered all that data, I'll let Robin reshare our PowerPoint here. We've either downloaded via the geospatial portal, or we've downloaded via AGOL, or we're in Pro and we've directly pulled the data in. So now what do we do with that data? So going back to our primary analysis question, for each RIA in my county, how much of the riparian area on agricultural lands has lost tree canopy since 2011? So we'll keep that in our brain as we go into our analyses process. So we're coming into this process, we've gathered and prepared the data. The next step is we want to determine that study area. So we want to determine the riparian area on agricultural lands. And then we go into identifying changes in the study area. So we want to look at the lost tree canopy within that study area. And after that, we have to calculate that change area. And then we'll export and interpret those results. And then we can go back into the gather and prepare data step for if we want to use other study areas. And we can just continue to do this flow over and over again with the data. So the data sets that we're going to use today, we're going to use the HRCD change locations to figure out those changes. We're going to use the Washington Department of Fish and Wildlife's riparian management zones. Those are based off of Washington Department of Fish and Wildlife scientific standards, showing our current best modeled approximation of the RMZ based on site potential tree height. And then we're also going to use the WSDA agricultural land use, which is readily available, so we're using it for this demo. San Juan County will later show that there's other data sets that you can use for this type of analysis. And then at the very end, we'll share some other resources from VSP for finding what's best for your county and your management plan. So we've gathered, prepared the data, and now we're going to determine our study area. So for our study area, we're going to take that WSDA agriculture, and we're going to add the riparian management zone. So in this, I'm going to be using the intersect tool to intersect those two layers. And my outcome from that will be what I'm calling the riparian study area. The RMZ in this case represents the critical area for this analysis. So from that point, we'll just move into that riparian study area. Once we have that, we'll go into identifying the changes. And so we'll take that HRCD changes layer, and we'll use the clip tool and clip the riparian study area onto that. So now we're taking a look at the riparian ag and land intersect. And then we're going to look at those changes, so the tree loss in that area. So using the clip tool, we get out the HRCD changes of interest. Because we've clipped things, there's a possibility that we have clipped a change polygon. In this case, I'm showing that we've clipped it in half. So we're no longer looking at that gray area. That's outside of the RMZ for our purposes. And so in order to get the correct information from this, we need to recalculate this area. So that will be necessary anytime that you use a clip or an intersect to try to change a shape. In our data table, that looks like these columns of total change at the very end in that red square. Total change, tree loss in acres, impervious surface increase, and semi-pervious surface increase. All of that needs to be multiplied by the new acres. So we recalculated our acres, and then we're going to multiply that by our change percentages to get acres of change. And Adam will show us a demo of this in a little bit too.
And that little bit is right now. All right, let me see if I can do the sharing. Share the screen. Okay. All right, so hopefully you all can see what I'm seeing. Let me minimize everything so I actually have access to stuff. Cool. So this is Pro, ArcGIS Pro, for anyone not familiar. And now I will be doing basically exactly what Emma just talked about. So for this demo, I've created just a random polygon to be kind of the delineating bounds of what we're looking at. And to give you an overview of all of these, we are looking at the WSDA crop layer, which again, all of these have been clipped to this area. We will be looking at the HRCD change locations. We will be looking at the RMZs, and then we'll be doing all these combinations and figuring out what actually is where. So to start with, should have pulled my notes up first. Here we go. Let's look at, we did a bit of this during the presentation, but this is what this attribute table will look like for the change location. So you can see everything that Robin was talking about. We have start years, end years, total changes, all of these various percentages. Scrolling to the right, we have agents, change origin, and then where these RIA, what RIA these are located in, as well as county in both. These are both FIPS codes, numbers, names, every kind of way we can describe them. And then finally, we'll actually be interacting on the far right here with these null fields and the acres of whole polygons. So the HRCD data set comes pre-made with these blank fields for total change, or for the acreage of total change, tree loss, impervious surface increase, and semi-pervious surface increase, to make it easy for you all to have a spot to put your calculations if you want to figure any of this out, which we do. So that's what we'll get into. First off, you remember the steps Emma talked about. We want to be intersecting the riparian management zones and the agriculture layer. And I say intersecting, that's the tool we're going to be using. We want to figure out where that overlap is. So I'm going to shrink this a bit. We come into our geoprocessing pane and search for intersect, and I will be running the pairwise tools of all of these. I mentioned that just so if you may not have access to this or something, pairwise just uses the CPU better, but it runs the same as the normal set of tools. So we will pull in first the RMZ layer, then we will pull in the crop layer, and we will run this tool. We will make sure it's always good to give descriptive names, because if you don't give descriptive names of things, then you'll come back to this in 9 months and have absolutely no idea what's going on. So we are going to call this study area. Save and hit run. The order of operations for this is slightly important. Whatever layer you pull in first, that's the symbology that will be pulled through to the final one. Doesn't cause any huge things, just kind of a neat thing to be aware of. So now you can see the intersect tool has run and we have our study area. So this is only the spots that contain both RMZ and WSDA crop layer polygons. And we will zoom in on something a little more important. So now you can actually see this. And so just to give you that initial sense, we have the crop layer and we have the RMZs, which look an awful lot like the study area because it's the same topology. And these are the areas that those two things overlap. If you wanted to do comparisons between change areas and the things we're about to calculate and broader areas that may contain changes or not, I guess, or not contain changes in this case, you could calculate the acreage of these new polygons and then export them into Excel so you can have those two data tables. We're going to do the Excel exporting in a minute, so we're not going to do it here. So now we want to run the clip tool. So we'll go back to our geoprocessing pane, search for clip. Once again, I'm going to grab the pairwise version. And now this is where order of operations does come into play. We want to be clipping the change locations. Come here. We want to be clipping the change locations, which look like this, by the study area. And once again, we'll give this somewhat descriptive name. I'm going to call this study area changes. We'll run that tool. And there we go. Hide this. So now we can see we have all of these little changes that are within our study area. So this is that triplet. This is the study areas that are within RMZs that are also within areas delineated as agricultural land. Let's get rid of that too. Now this is where we get into the actual recalculations. So because we've been doing a bunch of changes, we need to figure out the area we're working with. So I'll open up our attribute table again, and hopefully you all can see this. We're going to go all the way to the right to where we have these acreage fields. And the first thing is we've changed the size of the whole polygon, so we need to recalculate the acreage of the whole polygon. So we'll right click, go to calculate geometry. Give it a second, because it's pro. Cool, here it is. Some of these things might look pre-populated for you all. I've done this a fair number of times in prepping for it, so some of the fields may not have to be fully redone. But in this case, it looks like it mostly is. So we have acreage, that's our field. We set the property to area. We set our unit to US survey acres because that's what our coordinate system's using. And we're going to leave the coordinate system blank in this case because it will pull the coordinate system from the parent layer. And there we go. We now have our recalculated acreage. And we're going to do the same thing for total change. We're going to calculate its, sorry, we're not calculating its geometry. We get to do math on this one. We know now the acreage of these polygons. And if we go back to the left, we know what percentage of the polygons contain change. So we're going to come into total change and we're going to go to calculate field. And we are going to do the math. So we say we want, let's see if I can get this out of the way a bit. No, not really. Well, we want the total acreage. So we can double click that to add that field. And we want to multiply that by the total change percent. We double click that, builds our formula. You hit apply. And it went somewhere. There it is, center stage. So that now we have the total change in these new polygons. And we'll do the same thing for tree loss. So we'll come up here and change this field to tree loss. We'll grab our change percent and we'll replace it with tree loss percentage. And I'm going to hit OK this time because I don't need the window open anymore. And here we go. So it's a bunch of zeros up top, but you can see it now contains these tree loss values. At this point, if that's all you wanted, you can come up here and do the Excel exporting. So we'll search for Excel. We've got table to Excel. And this is where you would give it then, your input table, give it a good name, make sure it can do it as both XLS and XLSX, give it that extension name of XLSX. That's the new version of Excel. It defaults to the old version. I don't know why. But I'm not going to do that because I've already done that. So I'm just going to show you what that looks like. In Excel, you'll get something that looks an awful lot like this. In this case, this was an older version that I did. And so it has all of these fields calculated already. If we'd exported the other one, it just would have had the tree one in there. But here it is. It's got all of the data, it's got all the field names, it's got everything you want. But this isn't a lot of use in reports or giving to people who may not have any interest in what the raw data looked like. So we're going to use what Excel calls a pivot table and turn this into something useful. So we're going to start by grabbing all of the data, Control A, highlight the whole thing, come up to Insert, and we will go to this Insert Pivot Table. And we're just going to slap it into its own sheet here. So here's our nice little empty pivot table. Going to zoom in on this, so hopefully it is easier for you all to see. And now we will give it some data. So we're going to come in and we want to look at how much tree loss there was by Raya. That was our original question. So we're going to look at Raya name, and we're going to look at tree decrease in acreage. And there we go. Now we have a tiny table that updates itself in real time. If we change the other stuff, it all comes up here. And this shows us that percentage. But maybe we also want to look at how much was caused by nature versus how much of this was caused by humans. You can come in and say, change origin, we now want to pull in. And you can see that this now breaks it down in each Raya by these two change types. So you can see the acreage of anthropogenic change versus natural change in A, B, C as you go through all of these. Maybe this is a little much. We still want this info, but we want it to be broken down a little more sort of in table instead. So we can come in and do change origin. Let's see, that will move to filters is what we want to do. So now this puts it up top. We still have this filtering ability, but it doesn't clutter up the table quite as much if we just want something nice and simple and clean. We can change these around and see anything that we may want. And that, I think, is where I'm going to stop the interactive, the true part of the demo. I'll give a quick flash to, wow, that got real small again. So this is the sort of thing that is possible with these pivot tables. So you can see here, it is interactively filterable by these change types. You can see all of the individual change agents by these Rayas, all their various acreages across, and then you can add your own custom columns as well using just standard Excel formulas to do things like, in this case, this final column is what percentage of the total acreage of change is due to tree loss. And that's how we made that last column. And this can be turned into charts that update in real time, and kind of anything your heart desires, you can turn this data into. I believe that's where I will throw it back to you all. So we'll stop that share.
We do have a question in the chat
Yes.
from Kelsey. Is it important to select area or area geodesic when calculating geometry of this data set for detecting change percentage?
This is awesome. You guys are great. So area versus area geodesic, and somebody stop me as I go way off on this. Area geodesic is an important thing to pull in. It all relates to your projected coordinate system, whether you're doing a projected coordinate system versus the parent geographic coordinate system, and to some degree, which one you've chosen. The geodesic one, right? Yeah, the geodesic version is, I'm really gonna try to boil it down into words. It doesn't rely quite so much on the information that would have been coming in through the projected coordinate system, and it does its best to, oh, yes, thank you, Emma. This is where the pro people, Esri men, their documentation is usually pretty solid. It's a different way of recalculating things. Let's just do a long story short. If you're doing it in a projected coordinate system, running it in the standard is fine. If you're not doing it in a projected coordinate system, if you just brought it in a geographic coordinate system, the geodesic helps it maintain that area. It helps it bring in the flattening math that happens when you put it into a projected coordinate system. So I would say 9 times out of 10, when in doubt, just do the normal one, the non-geodesic. It's the default. It's one of those, if you know what these words mean, which we're watching me work through this, don't bother clicking it. You can do the normal one. It's fine. Hope that answers the question. The thing I'm gonna put in the chat will answer that question in a much better way.
That's great. Yeah, these are the types of technical questions that we love and projections. Our data, just as a side note, is presented in the state standard projection, which is a state plane projection. So that's for anyone who cares about projections, know that that is the default. So Emma and Adam just showed us our basic analysis process that we might recommend for analyzing our data. And it took Adam less than 15 minutes to answer that question of how many acres of change were there on riparian areas. So I hope you can see that, you know, going back to part 1 of this workshop series, we put in so much work. Our team, we have an amazing team of 8 people who create these data sets, and it takes months to create the data, and it can take 15 minutes to save you all time, take 15 minutes to answer that question using a GIS. So walk through this process, and we can do that again and again, not just on riparian areas, but perhaps on floodplains or wetlands or agricultural areas in general. And at the end of the day, if you repeat that process, you may end up with acres of change for each of the critical areas that you're interested in, and each of the RIAs. We gave up some fake RIA names, A, B, and C. They're very creative for this particular analysis. So with that, I'm actually going to we're going to take a break here for about 5 minutes. It is 10:48. Let's say come back at 10:55. And I'm sure someone might be here in the chat if you had some chat questions to answer, but and we'll just take a quick break and see you back in 7 minutes. And when we come back, we will look at interpreting those results that Adam just created, and how can we make meaning of these results? And then we will also come back and Maggie Long with San Juan Islands will present on how they have done an analysis using our data, which has some differences from how we do it as well. So there's lots of options. We look forward to seeing you in a little bit. So we will start back in 1 minute. If you are here, maybe add to the chat something that you're looking forward to this summer, or perhaps your favorite thing about summer as it's finally here in Olympia, fingers crossed. Hopefully other parts of the state have been experiencing it longer. Yeah, add to the chat what you're looking forward to this summer. It is 10:56. I'll go ahead and get started again. I see some things in the chat. Camping, sailing, hammock time. That's what I'm looking forward to this afternoon. Yeah, thanks for adding those in. I see some other questions in the chat, and I'm going to hold off on those, but I see some really good questions, and we'll make sure to answer those at the end. So feel free to keep adding them in. We'll make sure that none of them get missed. Okay, so we looked at how to explore the data, how to access it, how to do a quick and easy analysis to answer our question, and now we're going to interpret those results. Our primary analysis question, of course, is looking at the riparian area on agricultural lands and how much tree canopy has been lost since 2011. And the table that came out that Adam showed is a large Excel table that has a wealth of information in it. And we can summarize this table in so many different ways, including filtering for the attributes about the causes of change or the time span that you're interested in, the types of change, or even the RIAs that the changes occurred in. And Adam showed us a simple tool, Excel's pivot table function, and it summarized that very quickly for us. So if I want to look at anthropogenic change in RIA A, saw that there's about half an acre of tree loss since 2011. If I change this to looking at just natural changes, I can see that the natural changes that there were 3 acres of natural change. Being able to separate it like this is something that most change detection products don't do, because an individual has to look at every single change in order to assess what happened here and why. So once we look at these numbers, we also want to understand the accuracy of it. And we really delve into the accuracy of the data set and the details of that in the previous workshop. So I encourage you to look at that. Well, I'll just look at 2 numbers today. Our first number is the omission error, which is about 10% for our data set, which means that about 10% of real world changes have been missed. But it's a combination of modeling and human error, mostly the model. So about 10% of real world changes have been missed, which means that if we're looking at, say, 1 acre of change is what our data shows us at the end of the day, it's probably about 10% higher than that is what the actual change may have been. So instead of 1 acre, 1.1 acres of change is likely what we could have seen. Our commission error on the other side is 0%, meaning that every change that we display has been verified by an analyst using NAIP imagery that it has occurred. These pink outlines, as you see, we have the polygon, another polygon on the right here. And again, remember there's 25% new impervious surface, but all you see is the outlines. So we don't actually know where within the polygon that change occurred. Many changes have occurred are dispersed throughout the polygon. And sometimes they're clustered in one corner or another of the polygon. And sometimes that can create one other small issue around spatial uncertainty. That's worth mentioning here. It's kind of complex to explain, so bear with me for a second. But the spatial uncertainty is within the polygon. Where the change happened. We already know that it's within the polygon, but we're not sure where within the polygon that particular change occurred. And that only applies, this spatial uncertainty applies in two areas. One, when there's less than 100% change. So if 100% of this square polygon here has lost tree loss, we know no matter where we stand in that polygon or wherever we're interested in looking, that 100% that the trees were lost in that area. However, if the attribute also tells us that 50% of the polygon gained new impervious surface, we're not sure if that's the right half that gained new impervious surface, the left half, the top, the bottom, the center, or maybe it's a bunch of houses sprinkled throughout with yards around them. So that is a component that we need to consider when we're understanding this data set. And this isn't an issue most of the time, but when we clip the polygons like we have in this example, if an individual polygon has been clipped, we may have some spatial uncertainty around that. In this example, only 0.6 acres were within the study area. Again, if we use that calculations that Adam and Emma showed us before, multiplying the acres of the polygon by the percent of change, so that 50% new impervious, we're getting pretty accurate numbers. We're still getting accurate numbers based off of this distribution. But let's say we clip that polygon a different way. And our study area, the riparian management zone in this case, is more on the right. When we clip that, it's no longer 50% of the polygon that has experienced new impervious surface. So there are going to be some small values, some small discrepancies about the amount of change within the polygon. This occurs only about 12% of our change land has this problem. And it's nothing that you need to necessarily do about it, but just understand that there may be some fluctuations in the amount of change or where the change is when there's less than 100% change. This occurs a very small amount of the time, but it is worth mentioning. Another thing that is worth mentioning is to talk about total percent change. This is a really common question that we receive. The total change does not always equal a sum of the other types. And this may look like a flag to you. We often get questions of what's wrong with the data? And there's nothing wrong with the data. And I'll explain it. There's two reasons why this might appear. The first example why the sum of tree canopy loss and the development types might not equal total. Let's say, just like the previous image, we have an area that lost it's a 1 acre polygon, and the entire acre lost trees. And then a quarter of that acre also gained a new house. The total land area that has changed is not 1 1/4 acres, but it's just 1 acre. We just had two different types of change in one part. So we make sure not to count overlapping changes as duplicates. That often happens in development. And so in that case, the total change will appear to be less than the sum of the previous 3 types of change. Occasionally, you may see that the total change is greater than the sum of the previous 3 types. And that occurs with 2 unique change agents, redevelopment and retention ponds. These 2 change agents are quite rare, but we thought they were valuable to track. And because these 2 types of change agents they experience change that doesn't fall into one of the 3 types that we specifically track. So we capture that in the total change area. So for example, redevelopment includes a loss of impervious surface, a removal of impervious surface. And so with redevelopment, we might have a total change, say 50% of this polygon lost impervious surface, but we don't have a column for that. So we might just show up in the total change area as there was a 50% change, the cause was redevelopment, and leave it at that. The same thing is true for retention ponds or irrigation ponds, which we track, and that will capture the total area of that retention or irrigation pond within the polygon. So the main takeaway here is that if the total does not equal the sum of the previous 3, it's not a red flag, that is intentional. So once we understand, the table itself, we've looked at the data set, we've analyzed it, we have some numbers for our primary question, we can go through that cycle and ask the question again. And in this case, we've looked at the one in the bottom right where it says critical area changes on agricultural lands, and we have a value for that. And let's say the rate of change on that area was 1% of this area has changed over a 10-year period. But how does that compare to what's happening with the greater context within our county? What is happening on our agricultural lands in general? What's the rate of change there that we're experiencing? What's happening to our agricultural lands? Or what's happening at the RIA scale? Are there other factors at play at the RIA scale? So people may use this comparison to understand program effectiveness. We often think of programs that just try to encourage development to move away from critical areas and move away from agricultural areas so that we may preserve both of those, the viability of the agricultural lands and the functions and values of the critical areas. And so we may have a higher percentage of change outside of the agricultural areas and outside of our critical areas as well. And our change detection data is covering the entire county as long as there's LiDAR available. So you're able to run these complex analyses outside of just the critical areas. Once you have these data sets, you can also compare it in other ways. I encourage you to consider incorporating the Washington Department of Fish and Wildlife's high-resolution land cover data, which our team also produces. The land cover data includes a variety of land cover classes like trees, medium height vegetation like herbaceous or shrubs, and low vegetation like herbaceous areas. You can use these data sets for 2011 to go back and calculate the baseline vegetation amounts. For example, we can use those same riparian management zones, those RMZs, and calculate how much of those areas had trees or shrubs in 2011. Where did we start from? Let's say maybe by looking at the riparian areas in 2011 and looking at that land cover, we see that 80 acres or 80% of the riparian ag area had trees and shrubs or vegetation cover. Then after that, we can use the high resolution change detection data, the table that we produced with Adam and Emma, to see how much of the original area has changed. If 100% of the riparian area in 2011 was covered in vegetation, or if only 5% was covered in vegetation in 2011, the change is going to mean very different stories. So being able to tell the bigger picture, the more stories, rather than just the number of acres that have changed, it's going to give more meaning to your analysis, allow you to tell a better story for your 5-year reports. Another thing to consider that we often ask people say, well, you only track negative changes. Why are all changes bad? And we go into more of that in part 1, but I like to encourage you to consider that not all changes are bad. And this is where your local knowledge will come into play. For example, on the east side, forest thinning is not necessarily a bad thing. In this particular example, the forest was thinned around a house, and that prevents to help with insects and disease and forest fire mitigation. Additionally, retention ponds is something that we collect. In this particular example on the right, vegetation was lost, agricultural land was lost, and an irrigation pond was put in. Are the net effects of this negative? Are the net effects of this positive? This is something for you all to decide, but I would not consider every change to be a bad change. Additionally, restoration sites may also end up as changes. We see restoration sites of vegetation being removed, perhaps invasive vegetation being removed, and native vegetation being replaced. The impacts to that, the impacts on functions and values vary by critical area, depending on what you're looking at. Thinking about habitat, that kind of change will have a different impact on the functions and values of habitat versus the functions and values of floodplains. So I encourage you to incorporate local knowledge. You can bring in knowledge of local projects, conversations with landowners, site visits, individual stewardship plans, or best management practices. By exploring each of these, you can learn more about the intention behind the change. You can assess the present status of an individual change. If invasive species were removed along a river and replaced with native riparian plants, how long will it take those native riparian plants to mature and offer full functions and values? That's a slow change and not something easily captured by our data set. You can also estimate gains and functions and values using BMPs. So using that local knowledge and knowing that we can't know everything about the state through our change detection data set, I'm going to invite Maggie Long with San Juan Islands Conservation District to present on how they incorporated this data.
Thanks, Emma. Hi, everyone. I'm Maggie. Working with the San Juan Islands VSP program and also the district's data. Next slide. So today we're gonna walk through an example very similar to Adam's, but specifically in the context of our work plan and how we are using these results in our reporting. So we'll start looking at the different data sets that we've chosen to use. This will be different for everyone's county, but just to give you some more ideas. Then we'll go through the workflow. We're sticking with the riparian management zone and ag intersection, but we'll pull in some data from all the critical areas. And then tying it back into our work plan, and we'll bring in a little bit of that, the enhancement metrics on how we acknowledge the changes, the losses that are captured in this data, while also using other metrics and assessment tools to measure those gains. Next slide. So for our requirement, our analysis, the data that we needed was the HRCD change data, a map of agricultural parcels. So this was our choice instead of the cropland layer, and then layers for each of the 5 critical areas. Next slide. And next slide. So for our farm parcel layers, we chose to use tax parcels from the county, and we have identified a base set of parcels that are engaged in commercial or non-commercial agriculture, and then the district updates this layer anytime we write a new ISP, any instance of technical assistance or cost share, and we archive this layer. So if we ever need to go back and run the change analysis from a previous year, we can do it with the appropriate tax parcels from that time period. Next slide. So for our fish and wildlife, we chose to separate it into a stream and riparian habitat and an upland habitat. So we technically are running this analysis with 6 different critical areas. Our stream layers come from the Wild Fish Conservancy, and we've added a 200-foot riparian management zone based on the site potential tree height that Emma mentioned earlier. Next slide. So our upland habitat is probably our most complex layer. We're pulling from the Natural Heritage Program plants, priority habitats and species, and then also local habitats and species identified by the county. And these have also received buffers based on the species or habitat in question. Those vary from 25 to 100 feet. Next slide. Wetlands, pretty simple. This is a county layer that we borrow. It shows both tidal and non-tidal wetlands. Next slide. CARE is pretty easy for us. All of San Juan County is designated as critical aquifer recharge areas. And frequently flooded, we use FEMA's flood insurance rating map. Again, provided by the county or available through the county from FEMA. And then lastly, for geologically hazardous areas, we use soil data from NRCS, and we've pulled out all the soils in the county with a capability subclass of E. The county also has identified soils with a slope of 15% or more as GHAs, but as most of our farming is occurring in the flat lands, we chose to exclude that from our analysis. And next slide. All right, so we'll go through our example with the stream RMZ intersect with those ag parcels. Next slide. And we'll start that by tying it into our work plan or our adaptive management plan. So for each of our critical areas, we have our goals, and then the benchmark identifies the assessment tool and what we're measuring. So for our streams and riparian areas, that benchmark is maintaining the baseline rate of change of canopy loss, and then both development metrics within the riparian zone. And we chose to go with the baseline rate of change rather than just any change, because we want to acknowledge that those changes are going to be happening. What we're interested in is that they're not happening at a quicker rate than they did before 2011. And in San Juan, we're lucky we have HRCD data starting from 2006. So we do have 5 years of change data for our pre-baseline rates. And next slide. Okay, so walking through the actual analysis, once you have the HRCD data in ArcGIS Pro or whatever platform you're using, I'm going to kind of speed through this part since it's very similar to what Adam talked about, but this table here is just some of the fields from the pop-up when you click on the polygon. And I've pulled this polygon out. You can see the imagery layer from before the change was detected and after, and our percent of tree loss and total change. And then down at the bottom, you also have your acreage for that whole polygon. And as Adam showed us how those change acres are calculated when you download the data as is, we'll come back to that later when we have to recalculate. So next slide. So we're bringing in our Wildfish Conservancy stream layers and then using the buffer tool to add a 200-foot RMZ. We'll then pull in the farm parcel layer. So here we have a single farm, and we're going to use the clip tool. This does the same thing as the identity tool. We just chose a slightly different geoprocessing tool. And that gives us our area of interest. So this green outline is riparian zones occurring on a farm parcel. Next slide. So this is a step that Adam didn't touch on, but we decided to calculate the area of those intersections before we brought in other HRCD data. So here we have our 6 critical areas and a total, which for us is the same as Arcara, but for other counties, you may want to include a total just of all ag lands. And then next slide. So now we're pulling in the change polygons, and again, we'll use that clip tool to get the changes of interest. So for this example, we just have those 3 different polygons that intersect both the RMZ and the farm parcel. And next slide. So here we get to do the recalculations. So we've added these 5 new fields. The next step is calculating the new acreage, and then finally multiplying your new acreage by those original change percents to get our total changes within our area of interest. Next slide. So then, like Adam, we took our data out of ArcGIS into Excel. This is a pivot table filtered by year, with the total changes and then the 3 change types. Next slide. And then we took those first 2 columns, the 2006 to 2009 and 2009 to 11, in this column here on the right. So the total change acres pre-baseline for each critical area and then all ag land, and divided that by 5 to get our rate of change in acres per year. In this middle column, we have the post-baseline changes, and we haven't redone this most recent round of analysis, so this only goes through 2019. And if we look at that whole period, you can see we're only meeting our goal of being the same or lower rate of change than our baseline data. But in the left column, you can see if we change the time period that we're analyzing, we're doing a lot better at meeting those goals. There's only 2 critical areas that have a higher rate of change than baseline. So the period of time that you're looking at will really impact how you can interpret these results and what they tell you about how VSP is working in your county. What we have decided is to use the 5 years since the previous 5-year report. So each reporting period will look at either 4 to 6 years of change data, and just say how we have been doing since the last reporting period. Next slide. Here's an example again of how to break these down even further. So looking at the change agent, and again, adding our own columns, so the percent of the total change for riparian ag intersects based on the change agent. So tree removal is causing most of the changes in our county in the ag riparian intersect. Next slide. And then tying this back into our overall goals. So HRCD for San Juan County only fits into our protection goals, but we also have the enhancement goals of adding new riparian habitat. So we don't have data from the 2017 to 19 period for that, but in the past 2 years, we've planted over 12 acres of riparian forest buffers. Next slide. So it's not a direct comparison because we're looking at different time periods, and the function and values of a newly planted buffer aren't comparable to a fully established one. But if you compare the 12 acres gained in a 2-year period to the 1/4 of an acre lost in a 2-year period, this is where we can kind of use the narrative side of reporting to expand on the results that we found from the HRCD data. So yeah, thanks for having us.
Thank you, Maggie. That was great. Great to see it in action. So I hope that those of you on the call have gained some inspiration and can see how we can use the same data set and analyze it in slightly different ways to answer slightly different questions. And we looked at our primary analysis question, riparian area on agricultural land and the tree canopy loss there. But remember that we can look at this in agriculture in general, wetlands, floodplains, any other critical area, as well as looking at different types of change. We also considered using the different fields and attributes that the data set provides, that we can look at this based off of how much the amount of change that has occurred in our area of study, or what types of change have we seen, perhaps due to natural causes, or forestry, or development? We looked at ways to explore the data visually or understand the location. How does the proportion of change on agricultural lands compare to the whole county? Or just the critical area of interest? And we've also talked about how does the rate of change compare over time? Or how is change changing over time? We walked through the entire process from exploring the data and the metadata and the attributes to analyzing the data that Adam and Emma shared with this sample analysis process. And finally looked at how to interpret the data and make meaning of that. And a lot of the meaning comes from each of you. That local context matters, just like we saw with San Juan Island. Change is not always good and not always bad. And it's really important to consider the critical area functions and values and how those changes may impact those for what's the question at hand. Of course, we always encourage you to choose the best data sets for your monitoring goals that's local to your area and incorporate that local knowledge when you're interpreting the data. So we have one more question for you. So you get out your smartphones.
And once again, you can use the phone for the QR code if you already have it up. This question will automatically come up. And if you're joining on a computer, you can go to the slido.com and enter that number. We're curious which parts of the process you're most excited about after listening to this. And maybe you have some more questions. We have a great question I see in the chat, and we'll address those after we do this little poll. But I'm just curious, are you more excited about comparing changes over time, looking at separating types of change in your data, examining those causes of change, or taking a look at the accuracy of the data, or using an easy analysis? Seeing a lot of comparing change over time. That fits, right? That fits the goals of the VSP monitoring. I'm glad to see that one. We have some other examining the causes of change. I get really excited about that one in particular, because as I'm going through these images, I'm the one, and Adam is the one classifying these causes of change. And it's really eye-opening looking at those causes and seeing what we see on the ground when we can't actually physically take ourselves in the past yet. Fantastic.
Yeah, this is great. Thank you all for interacting today. I see some questions in the chat. I'll leave up our contact information for everyone who's been involved in planning this today. Up here, this presentation has been recorded and the slides will be posted on both the HRCD website and I believe the Conservation Commission website. But I believe there are some questions in the chat, so I don't know if anybody wants to read those out and we can see how we can tackle those. And if there are more questions, we'll have time for that as well.
Maybe we can touch on Rebecca Rising's question from Skagit. Curious whether HRCD does a good job at detecting intermediate tree canopy loss within a stand of living trees. For example, insect disease or tree dieback.
Yeah, that's a great question. So those, of course, are natural changes, and we do capture those. Our process, the original process, we create these polygon segments, and we looked at some that were kind of larger, like that development, where like in the neighborhood. But we do have individual polygons that capture individual trees, and then Adam and Emma will look at that and say, yeah, this tree died, looks like insect, and they will tag that as a natural change. So we do identify individual changes in that way for an individual tree. And then sometimes those diseases or those sporadic changes may happen on a larger scale. And so you may get a larger polygon and they may identify that, actually only 25% of the trees died here. We So that might be captured in that way. So you might have an entire forest, but it might not be just this corner has all died, but every fourth tree has died throughout this forest stand. So that will also be captured in that way. But it is a challenge to capture that.
I put a few examples in the chat too. One is capturing two trees alone, and then one is kind of looking at a bigger event that happened in a larger polygon, but not the whole polygon is a die-off.
That's it for the questions in the chat at the moment. If folks have other questions, feel free to raise your hand or throw it in the chat. We do have time to support you with those questions.
We have nothing pressed. I might have one last little sentence to say on my tiny soapbox about the geodesic thing, because it got me thinking again. It's very important to know your projection when you're doing GIS stuff, your projected coordinate system or your geographic coordinate system, or if there's none applied, because Pro particularly can shift things in real time. So they look like they're aligned, but they're not actually. So as a slight correction to what I said earlier, the core is still true. Given the area we're working with, the difference between the two tools is negligible. But the error that comes from the geodesic versus the planar system, the normal one is the planar, is in relation to the distance of the study area from the center of the coordinate of the projected coordinate system. For us, we use what I'm opposed to here, the NAD 1983 Horn State Plane South FIPS, whatever, which is centered in Washington. And so our error, the error, that change between planar and geodesic, if you're running in that geographic coordinate system and analyzing things in Washington State, very, very tiny, because we're talking about a small area that is centered in our region of interest. But let's say you pulled in something like the USDA ag layer instead of the WSDA ag layer. Theirs is nationwide. It's based in the Albert Equal Area Conic Projection System, which is a global projection based around the poles. So we're about halfway down. There could be a bigger difference in the geodesic versus the planar if you're running in that case. You would have to be using that data as the source for each step moving forward to keep that coordinate system carried through. Versus what we did, where we kept it in our data set, was the core moving through. So that was the coordinate system that came through. But yeah, I just sort of wanted to harp on that, because it's not at all uncommon to go out, scrape the internet for data, and be like, "Ooh, these are cool," bring them all in, and now who knows what coordinate system you're using. And that could cause problems if somebody really put a microscope on you. Again, they're still going to be small, but that is my know your coordinate system soapbox. I can show you how to find that too, if anybody doesn't know and is interested.
Thanks, Adam. I'm just going to put in some ideas too. I know this training was structured to support counties participating in the voluntary stewardship program, but I think it was really great that we have folks outside of the VSP community, both at local jurisdictions and other state agencies attending. But I wanted to provide some maybe final follow-ups about how some of the information they provided could be applied into your VSP program. The last survey slide, we talked about accuracy of the data, and that was something that was flagged as something folks would like to learn more about. If you weren't able to attend the first training, part 1, it covers a little bit about the accuracy of this data, both the commission and omission rates, as well as the analyst review process that really improves the accuracy of this data. Our agency has folks that look at every area flagged as change, so that the data we provide to you has a high accuracy of what the cause and type of change is. We also have great resources on the HRCD website that talk about the accuracy rates. And as they noted in the beginning of the presentation, there's a whole bunch of tutorials information as well for helping folks analyze the data. The other one I want to mention is monitoring plans. VSP counties are putting together monitoring plans that are due this July. And The HRCD is a tool that a lot of counties use to monitor the impacts of critical areas. And if you have any questions about incorporating HRCD data into your monitoring plan or recommended language, please reach out. The team would be happy to assist you with that. And I guess my last two on there was technical assistance. We're hoping that the tools we shared with you today provide you with the skills and knowledge to be able to run this analysis on your own and in-house. But we recognize that you might need further assistance. So the great staff here today are available to provide technical assistance. We've got contact information in the chat as well as on our HRCD website. So don't hesitate to reach out and we can help you with the data. And finally, the fourth thing to kind of tie it into the VSP context is, as we talked about today, a little bit of like, what's your do something level? We heard a strategy from San Juan about the rate of change. Something VSP County should continue to think about is at what point are we required to do something to ensure that we are continuing to achieve our protection goals. Counties, there's a variety of creative ways to think about what your do something level is, but that I think is a really important context in VSP to ensure that we're meeting that no net loss protection standard for the program. So just wanted to share some ideas, a little bit about putting this training into perspective of VSP. Again, if there's any questions, we've still got some time to support you all. Thanks for participating in our training.
Thanks, Sean, for that. Yeah, like Sean mentioned, we are available for support. Feel free to contact me. My name is Robin Hale, and I've worked with a lot of the VSP coordinators and GIS specialists for different counties about 5 years ago. It's been quite a while since this last 5-year report has gone through, but I'm happy to work one-on-one and answer those questions along the way. So if you get stuck, questions about the data, is this right? Why does this number look like this? Always happy to explore that with you. And if you have interest in the high resolution land cover data or the riparian management zones that we showed earlier, I can also answer questions about that. Please feel free to reach out. We are here to support you all. With that, it looks like there's no more questions. So I will give you all time to go enjoy your hammocks and the sunshine and start your weekends early, hopefully.
Thanks, y'all.
Thank you.